Hi guys, today is Tuesday, May 5th, and this is for Math 1. We're going to be talking about graphing exponential functions today using a table to graph, okay? I'm also going to talk about, in general, what happens with our exponential functions, okay? So let's start our first example here. So I have y equals 3 times 2 to the x. Now, before I get into any of the graphing, what I want to do first is I want to remind ourselves what these numbers mean, okay? So remember that this one is my y-intercept or my starting value. That's what it starts with at 0. That's my 0 term. And then remember this one is the multiplier, okay? So I want to keep those in mind as we're working here. Okay, now just by looking at the equation, we know, and I could do this even before I get to my table, the y-intercept is 3, so I can go 1, 2, 3 and make a dot there. I can do that just from knowing the equation. And then the multiplier is 2. So since the multiplier is 2, that means that my graph is going to be increasing because my number here is a number greater than 1. So since my number is greater than 1, it's going to be increasing. Okay, so it's going to kind of look like this, like a J curve going up. We're going to make it a little bit more precise using some numbers, okay? So we already know our y-intercept is 3, so we can put that for 0 right there. So we can read that right off of our equation. And then we're going to substitute these numbers in, and we can use our calculator to help us if we'd like to. It's up to you. I'll show you with the calculator just so I can help you, but I'll also show you by hand, okay? So you can type in your calculator just this part right here. So I can put 3 times 2, and then I could put the little exponent button, and then whatever the exponent is. So for example, for the first one, -2. So see, I'm substituting in -2 there into my calculator, and I get 0.75. Same with the -1. I can substitute it in the same way. 3 times 2 to the -1, and I get 1.5. Now, remember, you have 2 other options here as well. So I could continue substituting in these numbers here, and I'll do one by hand just so you can see it. So I'll do the second power one right here by hand. So y equals 3 times 2, and then I'd substitute the 2 in for x. So 2 to the second power is 4. I have to do exponents first. And 4 times 3 is 12. Right? Now, the other option that you have is you can use the multiplier that we already know, which to me is easier. So I know it's multiplying by 2. So I know my starting value was 3. So to get to the next one, I have to times by 2. That'd be 6. To get to the next one, I have to times by 2. That'd be 12. And then to go backwards, if I was timesing by 2, I would divide by 2 to go backwards. So you get 1.5. And then divide by 2 again. So I think that's a little bit easier than taking your time to do all the substitution, but it works both ways, okay? So I'm gonna plot the points now. So -2, 0.75, -2 is right here. 0.75 is gonna be almost to 1, but not quite. It's about right there. -1, 1.5, -1. 1.5 is right in the middle of that box there. And then 1 is 6, so 1, and then 3, 6. And then 2 is 12. So 2, 2, 4, 6, 8, 10, 12, all the way up here. So again, it should look like that J curve that exponentials make. And then I'm just going to do as best as I can to kind of connect it together. Make sure you put arrows on both ends. Now on this side, remember the way exponentials work is they're going to get closer and closer to the bottom but never touch. So you want to make sure that your arrow goes kind of close to the line but not all the way on the line. Something like that. Not perfect, but pretty good sketch. Let's look at another one just to make sure we know what we're doing, okay? So let's look at another example here. Okay, so I want to label my parts just like I did before. Now you might notice that there's nothing written here. This is my multiplier. I can see that already. But you might say, well, what's my y-intercept or what's my starting value? You might think it's 0, but if I put 0 times 4 to the x right here, 0 times anything is going to make 0. So that would cancel everything out. So it can't be 0. So we have to think to ourselves, okay, well, what times 4 to the x would just give me 4 to the x? Well, timesing by 1 doesn't change anything. So that means that it must be 1 times 4 to the x. Okay, so this is my y-intercept. And we already know the 4 is our multiplier. So I could put my 1 right here for my y-intercept, and I can already graph it right there at 1. And then I can use my multiplier, or I can substitute. It's up to you. So I know it's multiplying by 4. So 1 times 4 is 4. 4 times 4 is 16. So to go backwards, I would divide by 4. 1 divided by 4, I can either write it as 1/4, or I could put 0.25, that's up to you. And then I divide by 4 again, and I get 0.125, or 1/16, whichever way you want to write it, it's up to you. And again, I'll show you with substituting just to be sure, okay? So if I wanted to use the substitution method, I would go like this, and I just take these numbers and plug them in. So let's say, for example, I do 2. So I'd go y equals 4 to the second power. 4 times 4, because remember 4 to the second power means 4 times 4. That gives me 16. You see it's right there. You're going to get the same thing. This is just a little bit quicker if you know what they mean. Okay, so now we're going to graph them all. So I have -2, 1.25. So that's going to be pretty close to the line. -2, 1.25 is really small. So I'm going to put it all the way down there. And I have -1.25, -1. Oh, that's still pretty small. It's not even halfway. So something like that. And then I have 1, 4. So right 1 up 4. And I have 2, 16. Right 2, 2, 4, 6, 8, 10, 16, all the way up here. So this is an even steeper J-curve, which makes sense because the multiplier is bigger. I'm going to connect those all together, again, as best as you can. It's not going to be perfect, but as best as you can. Make sure to have an arrow to show that it keeps going. Same down here. Again, don't cross your line. Just kind of flatten off there. That's what that looks like. Okay, so if you have any questions, again, feel free to message me through Remind or Google Classroom or email, whatever is helpful. Have a great day, guys.